In this video, the weights are chosen such that the reward is high when both of the robots are seen by the system. So seen by the system means that if one camera sees one of the robots and the other one sees the other, then this is considered a state where both of them are seen. Okay, so if the reward is high on the seeing both state, then the expected performance is for the system to always choose the configuration, so the allocation of movements among the cameras, such that it guarantees that both of them are seen, okay, or captured with probability, with very high probability. And I stretch this fact that they're captured with high probability because when the objective to be solved is acquiring, okay, then there might be degenerate solutions, which means that the probability of acquiring an object might be equal to 1, okay, and this might actually be possible in one step or two steps in the future, okay. So in that case, it might happen that the camera chooses, because the camera at the moment chooses the action which requires less movement, okay, so it would stay put whenever the probability of acquiring the object is 1, okay. And you can see this at some points where the camera is actually not seeing the object but rather following it close by, and the reason why it's not actually capturing is that according to the stochastic reachability solution that it has been calculating, the camera knows that in the next step it can actually capture it, okay. The system has now started working. The robots are moving around. And the high-level controller, the hierarchical controller, supervisory controller, decides how to allocate tasks such that the state of seeing both is always achieved. And this is a situation what I was describing before with the acquire, where the blue camera was trying to capture the robot, but the probability was so high that staying put would also achieve the objective. And this is another case where this happens. You might also notice that there is a certain delay between the actual command that goes to the camera on what position to move in the next step and what the picture looks like, and that's due to the hardware limitation. I mean, this camera, it moves and takes a picture at the same time, and of course, if this picture is somewhat delayed, the evolution of the pie chart over the course of this test kind of confirms that the behavior is as expected. You can see that the green state, the one we're seeing both evaders, is the largest one. And actually the times that each one of them is lost and is waiting to be acquired, the degenerate solutions that I was describing before, is more or less equal. So the black state, which is seeing one of the two, and the blue the other of the robots, is more or less the same. And the one where you see nothing is the least visited state.